Hello, this is Mrs. Scarple, and in this video I'm going to review writing the quadratic equations, quadratic equations in their three different forms from a table and or a graph. So if we look at this parabola that has been graphed, we can identify the vertex, which will help us with vertex form, and we can identify the x-intercepts, which will help us with factored form. When you have either vertex form or factored form, you can use it to help you get the standard form. So let's start with the vertex. My vertex is located at -2, -1. So the vertex form of this equation will be y equals x plus 2 squared, because it's always opposite the x value in the point, minus 1. The y value always keeps the sign in the equation. For factored form, when I identify my x-intercepts, I see that I have one at -3, 0, and I have one at -1, 0. So factored form is two factors multiplied together, and the x-intercepts complete the factored form, so we will be adding or subtracting to the x's. Now, just like the x value of the vertex form, these x-intercepts have the opposite sign when in factored form. So we will have x plus 3 times x plus 1. I'm going to use the factored form in this example to get our standard form. To do that, I take x plus 3 times x plus 1. So I'm going to go ahead and use an area model to do this. X plus 3 times x plus 1. X times x is x squared. X times 1 is 1x. 3 times x is 3x, and 3 times 1 is 3. Standard form is taking these terms in our area model and combining any like terms and writing them in order from greatest exponent down to the constant. So it's x squared, 3x plus 1x is 4x, and then we have the units plus 3. Now, one thing I can verify is to see if this is correct is the 3 is the y-intercept of our parabola. So if we look at our parabola, we see that it does intersect the y-axis at 3. So we can use our graph to verify that we have our standard form done completely. If we didn't have the graph, what we could look for to find the vertex is look at these values. When we have a vertex, it's the only y value that appears in the list. It should be like a mirror image or a form of symmetry on each, either above or below in this case. So we have our vertex at -2, -1. The x-intercepts will always have a y value of 0. So whenever you have a y value of 0, you know your x-intercepts. So if you didn't have the graph, you could use the table. Let's take a look at one more example. In this case, I can again identify my vertex. This time it's -2, -2. but my x-intercepts are not exact points. So I'm not going to be able to write my factored form just yet. In this case, I'm going to start with the vertex form. Y equals, and just like the last equation, it will be x plus 2 squared, opposite of the negative, and then this time we have a minus 2. The vertex was down 2 units. I'm going to use the vertex form to help me get the standard form. So the standard form will be, well, first I'm going to draw an area model. X plus 2 squared means I'm going to take x plus 2 times x plus 2. But we also have the minus 2 units that we have to use. And actually, I'm going to put that minus 2 in the color that I'm going to use for my standard equation. So that's the minus 2 units from our vertex form. So when I fill in my area model, x times x is x squared, x times 2 is 2x, 2 times x is also 2x, and 2 times 2 is 4. So my standard form is y equals x squared, 2x plus 2x is 4x, and then we have 4 units, subtract these 2. So 4 subtract 2 is a plus 2. Now, because I don't have exact values for my x-intercepts, I don't think that I can factor the x squared plus 4x plus 2. But also, if I look at this, my only factors of 2 are 1 times 2, and there isn't any way that I can add 1 and 2 to get the 4x. So I know I'm not going to be able to factor this. So to find the intercepts that I need to write factored form, I know that for my x-intercepts, y has to equal 0. So I am going to use the vertex form to help me find my x-intercepts. I'm going to replace y with 0. So we end up with 0 equals x plus 2 squared subtract 2. And I'm going to use inverse operations to solve this. So first I undo the minus 2 by adding 2, and we have 0 equals x plus 2 squared. Then to undo the squared, we need to take this square root of each side, but I also notice I wrote a 0 when I should have written 2 equals x plus 2 squared, so I apologize. So now we have plus or minus the square root of 2 equals x plus 2. I now need to subtract 2 from each side. So we have negative 2 plus or minus the square root of 2 equals x. This gives me my x-intercepts. Now remember, when we write factored form, we're going to have the x in each factor, but then we do the opposite of what the x-intercepts are. Since this is a minus 2, it will be plus 2. The opposite of plus square root of 2 is minus square root of 2. And for the other factor, we're going to have x plus 2 again. And the opposite of minus square root of 2 will be plus square root of 2. So I know this looks quite different from how we're used to seeing factored form, but this gives us the exact factored form, as exact as we can make it, because we cannot find the square root of 2 and come up with an exact answer. That's why we leave the expression 2 minus square root of 2 and 2 plus square root of 2. Those expressions, those two terms combined, actually represent one value. And this concludes writing the equations of a quadratic in 3 forms.